Welcome to EDU World Space.
In this exercise, we have to repeat the problem that we solved back in question 24, but now we have to add the influence of a kinetic friction coefficient, mu k, that is equal to 0.2. So basically, let me explain the setup. We have a block that has a mass of 60 kilograms that's on top of an incline that has a length of 5 meters and makes an angle of 30 degrees with the horizontal.
Wet. From the work energy
After
theorem,
leaving
the force
the incline,
F is given by F equals frac text KE,
the
where
block
KE
still
equals
falls
kinetic
for
energy,
2.5
S
meters
stopping
until it
distance.
reaches the
I'm
ground
given for object A,
at a
FA equals frac
distance,
100,000,
a horizontal distance
0.10.
r from the
For object
point
B, FB
where
equals frac
it left
225,
the
1500
incline.
equals 0.15 text makes n. And force ratio frac FA,
So our goal in this
FB
exercise
equals
is
frac
to
0.10,
find
0.15
what
equals
is
frac
the
2 null
distance
result.
r
A box frac FA,
and
FB.
also how much
Would you like a
time the
PDF
block
version of
spends
this explanation?
sliding down the incline. So first of all, let's briefly remember how we deal with inclined planes. Notice that we have this block A, and the forces that act on the block, considering now the friction force, are the normal force that the surface exerts on the block, the friction force, and also the weight force. Now I'm going to choose a coordinate system such that the y-axis is pointing downwards and the x-axis is pointing, actually I'm sorry, the y-axis is perpendicular to the plane but points downwards, and the x-axis is parallel to the plane downwards. And we can decompose the weight force into these two components. So we have that Fy is equal to, this is the y component of the weight force, is mg cosine of theta. Theta is the angle that the inclined plane makes with the horizontal. And Fx, is equal to mg times sine of theta. Okay, this means that in the y direction, we have Fy, which is mg cosine of theta, minus the normal force, and this is equal to 0 since the block is not moving in the y direction. So we have that the normal force is mg times cosine of theta. And in the x direction, we have the x component of the weight force, so mg sine theta. Then we have the friction force. Remember that the friction force is equal to the coefficient of kinetic friction times the normal. So we have to, the friction force is in the minus direction, and it's equal to mu k times mg cosine theta. And this is equal to, according to Newton's second law, mass times the acceleration. Now the mass cancels out, so we're left with g times sine of theta minus mu k times cosine of theta is equal to the acceleration. Okay. Okay, so we have all the information we need in order to solve the exercise. Basically, what I'm going to do is, first of all, to calculate what is the speed with which the block reaches the end of the incline. And the exercise gives us the information that V0, that is the initial speed of block A at the beginning of the incline, is 2 meters per second. Okay, so basically, I know how to calculate the acceleration of the block along the incline, so I can use the Torricelli's formula that tells us that v squared is equal to the initial speed v0 squared plus 2 times the acceleration times the distance traveled. So v is equal to the square root of V0, which is 2 meters per second. So we have 2 meters per second squared plus 2 times the acceleration, which is g. I'm going to use this formula here. Okay? It's g, which is 9.8 meters per second squared times the sine of 30. That's the angle minus 0.2. That's the coefficient of kinetic friction times the cosine of 30 times the length of the incline, which is 5 meters. So V is equal to 6 meters per second. And I'm going to call this, actually, I'm going to just call this V, but this is the initial speed of the block when it starts freely falling after it leaves the incline. Okay, so after the block leaves the incline, the only force that acts on the block is the gravitational force pointing downwards. And I'm going to change the coordinate system such that the y-axis points downwards and the x-axis points to the left. So we have that the initial speed, which I'm just calling v, along the x-axis is equal to Vx, I'm sorry, this is equal to v times the cosine of 30, since the initial speed makes an angle of 30 with the horizontal, and Vy is v times sine of 30. Okay, this is the initial speed after the block starts freely falling. So this is Vx is equal to 5.2 meters per second. This is 6 times the cosine of 30. And Vy is 6 times the sine of 30, which is 3 meters per second. So now what I'm going to do, remember that our goal is to find r. So I'm going to find how much time it takes for the block to fall these 2.5 meters. And then with this information, knowing the time, we can find what r is. So I'm going to use the equation for y. We have that y is equal to y0 plus Vy, that's the initial speed in the y direction, okay, times the time t plus 1/2 of gt squared. Now y0 is 0. I'm setting the origin of the coordinate system at exactly the point where the block leaves the incline. Y is 2.5 meters. And this is equal to Vy, which is 3 meters per second, times t plus 1/2 of g, which is 4.9 meters per second squared, times t squared. So we have 0 is equal to 4.9 t squared plus 3t minus 2.5. And that's it. So let's solve this with Bhaskara. So we have this t is equal to minus 3 plus or minus 3 squared plus 4 times 4.9 times 2.5. And we have to divide it by 2 times 4.9. Now notice that we are only interested in the plus solution, since the minus solution would give us a negative value of time. So the time t is equal to 0.47 seconds. R, on the other hand, is Vx times t, so it's 5.2 meters per second times 0.47 seconds, which is equal to 2.44 meters. This is the value of R. Now, the second part of the exercise, we have to calculate the time it takes for the block to slide down the incline. Okay, so notice that we can use the equation for an object that's moving with constant acceleration, so I have that v is equal to v0 plus at. So v minus v0 divided by a is equal to t. Now notice that the final speed of the block on the incline is 6 meters per second, as we calculated. The initial speed is 2 meters per second, as given. And the acceleration is g, that's 9.8 meters per second squared, times the sine of 30 minus 0.2 times the cosine of 30. And this is equal to, so t is equal to 1.25 seconds, which concludes our exercise.